Hey everyone, just wanted to shoot another video on explaining what this tool is. This is known as a set of dial calipers, or also known as verniers. This is actually known as a zero, and I'll point that out, starting at 0 all the way, see if my camera will focus, to 6-inch. And that's right there. So I'm gonna open these up. So they're kind of like a tape measure. There's your 1-inch mark, 2-inch mark, 3, 4-inch mark, 5, and 6. The lines in between those are your 100 thousandths marks. So you would see, let me zoom in here. That would be starting from 0, that's 0.100, 0.200, 0.3, and then so forth all the way. And then when you get to 1 inch, now you're at 1.0. So now when we go up to here, we are at 1.1 inch, 1.2 inch, 1.3, and then we keep going. This would be 2 inches, so 2.0, 2.1, 2.2, 2.3, and it just keeps going on. So what this means is when this is down to 0, well, essentially, you're not measuring nothing. It's just bottomed out. And you just, every rotation of this dial is 100 thousandths. See if I can zoom in here. Each line that you see is 1 thousandths. So there's your first 10 lines, and then 20, 30, 40, 50, and all the way around. There's 99, and then it just starts over again. That would technically be a full 100, but you're starting over. And then the little dots, see if I can even zoom in closer. I know these things are messy. Those little dots in between those lines are 1/2 thousandths. Or I should say 1/2 of 1 thousandths. Now all verniers are going to probably vary on that. My set that I own right here are probably 20 years old. And they do make some that have like a little thumb wheel right here. And they even make digital ones, which you can actually just close these up and just hit the re-0 mark. I don't have a set of those, but you can probably get those pretty cheap at Harbor Freight or something. So for each rotation of that dial is 100 thousandths. So say you wanted to take a quick measurement. I'll use this screw. I recently did a couple of projects around the house, and I wanted to drill a hole, just enough clearance for this to go through. And it's a little tricky to use on a tape measure. So say you look at it, it's like, well, it's probably close to 3/16. And I was like, I'll just grab my verniers and measure it. It's just go like this, boom, done. And if you're a beginner, you're like, oh, how do you read that? So what this is, you can actually lock it right here. You just sit there, just snug it up, and it'll stay put. Well, I'm already at the 100 mark. past that, but I'm not at 200. So you're like, okay, now we read, so we're at 100. Now we got to come up to the dial. And that's reading 65.5 thousandths. So in theory, you're almost reading at 4 decimal points. But most people would just say 165 just to call it close. Because you're adding this dial number to this down here. So 0.1, we're not at 2 yet, 0.1 plus 60, let's see here, 1, 2, 3, 4, 5.5. So 165. So what I ended up doing, I just grabbed a drill that was like a, I can't remember what it was called, what number, but it was like a .172 drill. It was just enough to act as a clearance, and that's all I wanted. Just the bolt, I'm sorry, the screw would just slide in and do what I wanted it to do. Here's a piece I made a while back at my old job, and this surface here had to be plus or minus a half a thousandths. So I would measure that with my micrometers. But when it came off the machine, I would just give it a super quick measurement all the way around using my verniers as far as the groove, this surface, this OD. This didn't really matter. This was plus or minus 10 thousandths. The width of the hub here, that was plus or minus 5 thousandths. And then there's an internal, I don't know if you can see it, there was an internal bore that a bushing went into. So, say your part comes off the machine, you wipe it down, and you want to take some really quick measurements. This part right here is meant to get into tighter spots because it's ground. You can see that. It's got that taper so you can actually get in and measure tighter spots. Then obviously on these flats, on your verniers, is where you do all your measuring on the OD. This part on this side is meant for measuring internal ID dimensions. I'll show you that in a minute. And then on the very end, you can actually measure the depth of a hole this way. So in theory, what I ended up doing was, okay, I already knew the dimensions I had to work with on all these. So I would have it come off the machine, measure that. That was almost 522. It's 521.5. I'll measure the OD here. I mean, it was super close. 625. Measured the bottom. 625. And I'm not pushing super hard. I'm just enough pressure. It comes with practice, but it's just enough. I'm not like wailing on it with my thumb. So, and I would recheck that with my micrometers. So in the OD here, it wasn't super critical. It was 1.750 plus or minus, I believe it was 10 thousandths or something like that. So that was fine. And then over here, the hub. You can see we're 0.501, so that was within spec. Let's do an ID measurement. Let's go like this. Sorry about the lighting. My arm's in the way. Okay, everybody, I just wanted to show you a better view of measuring inside. You can see in the picture there's a little bit of a glare, but I'm trying to get as best I can. I bored this here to a certain dimension, and these verniers can actually measure it really quick. So you can actually go up against the side, come down, Actually, let me just put these a little further. And then you can just bring this down and get your dimension. 554. As you can see there, you got the 5 on the dial, and you're not at 6, and then you just take your reading on your dial, which is at 54. So you got a total of 554.554. All right, so I'll have more videos coming out on the tools I used in machining, and also I'm going to do some videos on CNC programming, because I was running 3 Haas CNC lathes, and I learned some tips and tricks as far as programming, so I'll be sharing that with you guys coming up soon.